So hello, my name is Jason Michalski. I'm going to be talking about Pyramid today. I'm going to be going through showing code examples mostly, and the plan is to contrast what we see with what you would see in Django, and feel free to ask questions and interrupt as we're going through. So there is more than one framework which can have a single page app. It's not the normal way that you would use Pyramid, but it makes much nicer slides when everything fits here. And also, Pyramid can scale up with you, so you can start with a simple one-page app and not make any big changes and just keep adding on to it. So this example here, it looks very similar to a Django app. You have a view callable, which takes a request and it returns a response object. We see that we are configuring a route on a configurator object on line 11. In this case, we're naming our route hello, and we're capturing the name after it. You'll see that unlike Django, we are not using regexes to match our URLs. We can configure these matches to have regex components to them, but no one really likes to manage regexes in their urls.py, or I don't, maybe you do. One other thing we see is that we're registering our view below, where we're registering view callable, and we give it a route name. We'll see later on why it's useful to not directly register your view callable to a route and instead have this extra level of indirection between them. The configurator object we see here is how we configure everything in Pyramid, but there are shortcuts, so you don't have to actually use this configurator object, which we'll see now. So we can use declarative configuration, and here you can see that we switched from using the configure.add route, and we now on line 6 are using view configure with the same name. And this is a very simple one-to-one mapping to the configurator object. And we can see in this case it's essentially identical. All we've done is use this decorator. So one nice thing about the declarative configuration is that even though we're using decorators, it's not modifying your function at all. So you can still test it by just calling it, passing in a mock request here, and then you get back the response object directly, and you don't have to worry about anything replacing your function, and if you try calling it, not having access to it anymore because it's decorated. So one other nice thing about Pyramid is that you can modify your request object to attach your own properties to it. In this case, we're using a very stupid database, an in-memory Python dictionary. So we are making a factory which returns our database connection, which is a reference to our dictionary. And we can see that on line 19, in our add request method, we're adding this make database connection and calling it DB. So now inside of our view, on our request object, we can just say db.get to call the get method on our dictionary, and we can get our name, or we can get the age of our member, or Bob in this case. So we display Bob's age. One other thing we see here is that there is no ORM included. You can use anything you want here at this point. There's lots of plugins and extensions which you can use to integrate with SQL Alchemy, Mongo, pretty much anything you want. And it's very simple, as you can see here, to integrate with your own connection management system to any database you desire. Templating is, there's 2 templating engines included. There are adapters that you can install for pretty much any Python templating language, and we'll see later how simple it is to use them. So here we're now doing something that looks very Django-like, is rendertoresponse. Instead of passing a string like you would in Django that has your just template path, we are using a asset specification which has the Python package name, which contains this template, separated by a colon and the path inside that package. So what this lets us do is actually have our applications completely installed by pip and be able to find these packages easily, and you can have 2 different applications with the same exact or two packages installed with identical template names, and there will be no conflicts. And you can also, in your configurator, use the asset specification to override a different application's template. So in this case, we're using this render to response so that we don't actually need to build a response object ourselves. So one thing we want to do after this is remove some boilerplate. So what instead of calling render to response, because that would get old quickly, we can just return a dictionary of values that we want to be rendered. And in our view configuration, we can add a renderer, which in this case is just the actual specification to our template. And it will be rendered for us automatically to the response. And because our view configurations are not actually doing anything to our function, now when we write our unit tests, we don't have to test on the HTML output that was coming back in the response object. We have the direct dictionary coming right back to us. In Django, when you run your unit tests, you normally are using the test client, which has hooks in it, which capture the output onto your response. So you have a response.context, but that only happens inside of your unit test when being run inside of the actual test client. So what this lets you do is you can actually compose your views in your code because they're just Python methods returning dictionaries. So at this point, there's no magic involved at all. And as I said before, one reason we want to separate out the difference between having a route and a view and the actual view registrations and link them together by name is we can configure the same route to have multiple views. In this case, we're using the same view callable, but we're introducing a view predicate. In this case, XHR equals true. So all of our AJAX requests will get a different renderer. So the same data will be generated, but we'll render in two ways. And in Django, you would normally do this probably with either an if statement inside your view, or you'd use a class-based view, which hides the if statement from you and makes a call to do different renderers for you. So it simplifies out this kind of dispatch logic into one place inside the framework for you. You can also register custom renderers. In this case, we are configuring the built-in JSON renderer with a new adapter that knows how to format datetime objects as ISO formatted datetimes. So in this case, we are just making an instance of the JSON renderer. We have a simple method or function that takes a object and request and formats it for us and returns it. And then we're registering it with Pyramid in the configurator by adding a renderer called JSON with the instance of our JSON renderer. And now below we can just return a datetime object and it will be properly serialized as an ISO formatted datetime. You can also have response adapters if you don't want to actually have to return a dictionary or a response object. You can return any type you want from your view as long as you register a proper adapter for it. In this case, we are registering an adapter that adapts any string into the text HTML response object. So we register this once in our configuration, and now any view we have can just return strings, and we don't have to worry about returning anything else. There's probably no useful reason you want to do strings, but if you're writing an API server, it would be, and you already have lots of classes around, and maybe you're using a different ORM, you can very easily see how you can automatically make a response adapter. So you can just return an ORM object and have it parse it and serialize it for you, so you don't have your views actually needing to do any of this work. One thing that you can do in Django is use context manage, or yes, yes, context processors, and to inject or their template.
They provide global values to any template library.
Yes.
Yeah.
Yes. So the way that you would do this in Pyramid is you add a subscriber to before render, and it's an event that fires immediately after your view returns its values, but before the template is rendered. So you can have access to all of the values that are passed into your template and add any new global template values. In this case, we're adding a site name to every template that gets rendered. one thing that's very not Django-like is traversal. It allows you to not use pattern matching on URLs to route. Instead, we use a file-like system where, like Apache loads a page, it just traverses your file system directory by your URL you give it until it finds a file and serves it. What we do is we have a tree of dictionary-like objects, which we traverse just like a file system to find the object to render. So instead of finding a file, we find an object which becomes a context which we render in, and it gets passed to your view callable. It's very strange at first. Once you get used to the concept, you can do some very powerful things. So with traversal, you take a URL like a/b/c. It gets broken into the individual components, and there's a root object, and it just simply uses Python dictionary lookup to call it until it gets the actual callable. If at any point in this you get attribute errors, traversal ends and that's your context, or if you get a key error, you get a 404 page. So a very simple example is our root object really is here just a dictionary. It has one value in it, Bob, and Bob is another dictionary with a name and an age. We build a root factory, which in this case just returns our dictionary, but you can actually use the request object here to look at the host name and possibly do virtual host type applications by returning different roots. We have a simple view callable here, still hello world. Now instead of just taking a request, we take a context as well, and we return a response object, our same one as before. But now we don't have to do any sort of database lookup or anything inside our view. We are handed the object that we want to render, and all we're responsible for is rendering the object. And on the bottom we have the example of if you go to /Bob, you get the text rendered, hello Bob, 40 years old. So we can also add view overrides by name within traversal. In this case, what we're doing is we're adding a second view with the name Yell. So when we go to Bob before, we are dispatched to hello world, and we say, hello Bob, you're 40 years old. But if you go to Bob/Yell, now the last trailing value after the context we resolved is the name of the view to render. So now we get dispatched to what probably should be called Yell, but I was going to mock Bob, but now I'm just yelling at Bob. And we can also vary our dispatch based on the type of object that traversal found. In this case, we added Jill to our dictionary, and Jill is a tuple, not a dictionary. So in our view configuration, we see that hello world, the first hello world has a dictionary context, and the second takes tuple context. So now in this case, the first hello world will be getting a dictionary object and rendering it. The second will be getting a tuple and rendering it. So we can dispatch based on the view names, the object types, and any other view predicates we want. So we can add actual view predicates for gets, posts, content types, and you can actually register your own as well. So other cool stuff you can look at, there's tweens, which are the middleware-like. They sit in between the router and your upstream WSGI application. Add-ons are very simple to write. There's a config.include, which includes a third-party Python map module, and it passes it your configurator, and you can give a view prefix for it, so it can reconfigure your application for you automatically, add views into your application, modify your request object, everything like that. As I said before, using the asset specification, you can override the third-party views without touching their code. You can override their templates without touching their code or anything. Security, you can have per resource ACLs. Anywhere within the actual traversal hierarchy, you can add a dunder ACL, which is a list of tuples of access control, and it'll hierarchically disable entire components of the tree. So if you have a hierarchy where you have a document, or maybe you have a whole blog and all the blog posts, you can set an ACL right on the blog, and then all the blog posts below it will inherit the ACL permission. You can replace almost all of the guts of Pyramid with new implementations. So you can add new renderers, you can add new resource URL adapters, which are how resources know their own URL, but you can change how they figure out what their own URL is. You can add response adapters, as we saw. You can change the entire traversal algorithm if you like. You can add your own route predicates. You can add your own view predicates. You can change up the entire request object, not just add new methods to it. You can change session factories. So if you want entire different session management, instead of using cookie-based sessions, you can save your data in Mongo or Redis or a database just by changing out your session factory. And you can also set a view mapper, which entirely changes the calling conventions for your views. If you don't want a request object, you want some new objects, you can write it completely differently. If you want Django style, where you get all your captured variables from a route passed in, you can give a new adapter, and you get a new calling convention to your views. Any questions?
I
Yes.
just want to say I like that transmission plugin. I didn't know that it was available.
Any other questions? That wasn't actually a question. Is there a first question? Come on, there must be some questions. This thing looks nuts to me. Someone must have questions.
So, Pyramid looks like it has a lot of power and a lot of configurability, but is there a quick way to get started for somebody who doesn't know anything about it and just wants to see what it can do with their own?
One thing that they include are essentially scripts that will build you a default-ish application, much like Django has, where you build an app, and there's different templates it can build. So you can say, I want a SQL Alchemy app, and it will build you a scaffolding for a SQL Alchemy app. You can say, I want a ZODB app, it'll build you scaffolding for a ZODB app. And those are another thing that can be configured by a third-party extension. So there's third-party extensions that will add essentially a whole framework on top of Pyramid, if that's what you like.
You just build an ordinary distributed application for this, right?
Yes.
Another question, how long does it take to just install the basic system? Because I looked at Pyramid a while back, and there's a long-ass page. It was like a video of an old guy talking like half an hour about how to set it up.
I mean, there's not much to install compared to anything else. Pip install and gets all your requirements, and you can just use pcreate to create your sample application.
Just like 10 minutes?
Yeah, should 10 minutes, assuming you have pip and Python working already.
So how would you decide between this and Flask, other than the arm wrestling we're going to do?
It depends on, I mean, I haven't actually used Flask much, but it depends what you're trying to do. I can see that if you are starting small but expecting that you're going to need lots of configurability, and if you ever get to the point where you hate your framework and you want to replace half of it, Pyramid will not get in your way and let you say, get rid of it without forking the code or making any actual changes to it. It has lots of extendability built in. Yes?
Was Pyramid in fact written by aliens?
No, it was not written by aliens.
Now, since we're talking about origin stories, we should mention how Flask got started.
Oh, yes.
Because Flask, originally there was a one-file micro framework called Bottle, and Armin Ronecker, who wrote Flask, decided to make fun of it on April Fools and wrote a thing called Flask as an April Fool's joke.
It was called Denied.
Fine. But it grew up into Flask, and so Flask actually started as an April Fool's joke, which is amazing.
Yes?
What's the relationship between Pyramid and pylons?
The difference is that pylons became Pyramid 2, or pylons 2 essentially is Pyramid. Pyramid came from, what project was it? BFG. And the two combined, essentially, pylons got to the point where they realized that having class-based views as their base was a very fragile way to work, in that they could not change any of their base, because when you inherit from the class, all of its internals essentially become public, and if you change any of the calling conventions inside, everyone depends on you. So inheritance is fragile, don't do that.
So there's a long document about Pyramid, the design decisions.
Yes.
And clear to defending it, there's been some criticism. I understand it also includes zouk components,
Yes.
but there's, I'm not quite, it's not quite clear to me if some of those are now discouraged by like the core, some of the core zouk framework.
They would defend their choice of using zouk components, saying that you don't need to know they exist. They're magic behind the scenes, and all the view dispatch is actually done through them, which means that all the view dispatch is being done in C code. So it's actually quite fast to do all these lookups.
I'm kind of new to Python, but isn't magic a bad word? Like, if you're defending a design choice of the word magic, isn't that like you get hit for that? I don't know. I just want to.
The point of frameworks isn't to get rid of all the hard stuff for you and give you a nice, clean-looking API. So if magic happens to be behind the scenes, but it's comprehensible magic, it's good magic.
So white magic and black magic.
Yes.
Any other questions about pyramid?
Yes?
So when starting off with pyramid, what are some of the doctrines that have to advise?
I think
Starting off with pyramid.
yes, I guess the biggest things are that there's so many ways to do things, and depending on what templates you're working with, you can get modules that won't work at all, or maybe you're using third-party modules that are using completely different templating systems than you're using. Just the amount of configurability and choices is probably the biggest problem, because no two people will use it the same way.
Is there a developing set of best practices to manage that?
I think essentially the way it's working is people are building higher level frameworks on top of Pyramid, and they will make choices and be opinionated for you, but Pyramid is not opinionated.
And what would you recommend in content management system plugin? Because I've looked at some for pyramid.
I haven't used many content management systems so I don't have a good choice or preference.
So for getting started, is there a higher level framework that usually when there are a set of higher frameworks, one of them is optimized for having a graceful path to the underlying system?
None of the ones I've seen have actually sort of hidden any of the workings, so they just give you a bunch of sensible defaults, and you can still go off and use all the Pyramid functionality, and they're not hiding it from you.
Of those, anything you suggest?
I haven't personally used any of them either, so I don't have any suggestions.
All right. So you mentioned that some of the dispatch code has zouk ancestry, and we've seen that there are many, many ways to control what actual code snippet executes, generating a response. Given a live Pyramid application, is there a good way to tell where in the code is this response coming from?
There are a few tools. One for routes, there's a simple way to display all the route-based dispatch. And I believe it will actually give you a tree now that shows you the predicates choices that exist, but I'm not 100% sure. I believe there's also a debug toolbar plugin that's a lot like the Django debug toolbar. So when you actually are looking at a page, you can see what was actually dispatched to.
So you said there are many ways to do things. So were you saying pyramid is non-Pythonic?
Sure.
That seems like an unfair criticism. Are there any questions about any web development topics at all outside of Pyramid? We could go back to Flask, or we had a few Django questions already, which we could permit. Anything on people's minds?
Could someone say like 2 sentences about what zouk is as a background for those of us that don't? Like, is there a reason it's like a controversial thing? Or
anyone want to answer that? Why is zouk a controversial thing? No one?
I have lots of opinions, but I'm not sure they're fair. Zouk was in a installation bound to a very early version of it and poorly maintained. But if we could extend the metaphor of the elephant from the last presentation, zouk is a herd of mammoths that somebody has tried to crossbreed with flamingos. It is a very heavy framework with, at least in the zouk 2 installations that I saw, a lot of dangerous black magic that, you know, depending on the order of your URL, things will resolve as object lookups, attributes on objects, in sort of unpredictable manners. It's a very heavy framework in the early days of the web. So, you know.
When you implement your own database, you're definitely a heavy framework.
Right. So yeah. So zouk. Actually, my introduction to Python 12 or 13 years ago was through zouk. But I don't know that much about zouk. But it was a very early framework. It was very. It was trying to do a lot, and including building its own object database, ZoDB. If the remnants of zouk that you find outside of zouk projects, for instance, inside pyramids, tends to be some of their helper libraries like zouk adapter and zouk interfaces. So zouk adapter is probably in there, right?
Yes.
That's how you put it in int and it finds it.
Yep.
So zouk interfaces is a way of getting Java-like interfaces in Python, including the concept of adaptation, where you can say, I expect an int, but all I have is a thing, and you somehow have registered how things can turn into ints, and it will find them for you automatically and make the data work somehow, those sorts of things. So yeah, it's very cool. Magic.
Yes.
Right, it's powerful magic. The people who like zouk interfaces really like zouk interfaces. Twisted is built on zouk interfaces as well.
So you use the term like inheritance is evil or something. So I recently started learning Django, and just when I hit the class-based views, I just had no idea what was going on. And just wondering if, what other people's thoughts are, because till then everything was a neat function, it all made sense, and all of a sudden there's like 20 things in the inheritance hierarchy, and I have no idea where code's coming in from, and so any
I
can
would
you elaborate on your inheritance is evil kind of?
I would tend to agree that the class hierarchy of Django class-based views is rather frightening. And I had the same experience of not knowing what's where or what functions would be called when. And you just read through their classes repetitively until you know what's going on.
I'm going to step up again since
Okay.
we're all over doing your presentation.
Good.
Put it. And
Yes.
Flask has class-based views optionally if you want to use them. I think it's mostly implemented via an extension. But the fact that that exists shows that people have a need for them. That you can do function-based views and they're great while you're small, but at a certain point when you're trying to do lots of different things, like let's say you have a single URL that needs to respond differently to a GET request versus a POST request versus a patch request, and all of those things need to behave differently whether you're logged in or logged out, and they all need to respond to either HTML or JSON or XML. At that point, when you're doing lots of crazy stuff that all map to the same URL, it's really, really helpful to be able to logically break it out into one class that handles everything for that URL, but logically split up into methods on that class.
That I would agree that is a good thing. Pyramid can do that as well. In Pyramid, the class is given the request parameter and a context parameter, and then the individual methods are called on it.
Come on, fight.
But there are no base classes you inherit from that have magic going on calling you, and you don't set template name on a class and magic happens that renders your table.
I've been confused by class-based views as well. I think it seems like they're the kind of powerful thing that if you designed the classes, you would have a lot of power, but if you're looking at someone else's classes, it's very confusing because you find yourself going up and down the inheritance chain to try and follow the path of what's happening to your request. And it's very difficult to know how that works. And the defaults, the built-in class-based views that Django gives you are actually quite deep in terms of the inheritance chain. And so there's a lot of places to try to understand what's going on. Each of them individually is surprisingly simple, but by the time your actual request is happening, you have to go through a lot of simple little things to figure out what's going on. Our third speaker is here. And Ricardo was going to speak about, his throat's a little under the weather.
Yes, so sorry about that.
We'll get you up here, but the topic is?
The topic is basically Zouk?
Zouk. I told you we already had a question about Zouk.
Right.
Yes.
Let me field the question first.
Well, you get set up, and the mic here will help you. But another question while Ricardo's getting set up?
The Flask presenter talked about the classes in the Flask, and I ran across something called Flask Classy, or is that
That's
what
what I
you're
was
talking
referring
about?
to, yes.
Okay, so it's unnecessary to use, but it might be a good idea if you've got these really complicated requests. Is that a fair summary?
That, I think, is a fair summary of most Flask extensions.
Okay.
If it's not necessary, it's not crucial to a small web application, but if you are in a situation where you need it, then it's there for you. So, yes.
Okay.
Another question? Yeah.
Just more of a general question for everyone. What if anybody's familiar with the templating language for Python that is analogous to Git in Scala or Line Closure?
I don't know what those are, so I don't know if there's one like it.
So those are both templating techniques which use CSS selectors as the basis of doing templating. Instead of using Django style templating where you have a syntax unto itself that has control blocks.
Right. So the question is that there are some templating languages and some other programming languages that are based on CSS selectors, and does Python have anything like that? Does anyone know? I don't know. Does anyone? What? You know? No? Okay.